In this video, we're going to be talking about biomass energy and nuclear energy. Biomass energy is just energy from organic matter that includes plant materials and animal waste. About 10% of primary energy use in the world is already from biomass energy. This is because so many people in the developing world use wood and charcoal, which is made from wood, for cooking purposes. Bioenergy is considered a carbon neutral source of energy. And if you think about that intuitively, it's because when plants grow, they absorb carbon dioxide for photosynthesis. And you can then harvest those plants and put them through some kind of process like gasification to create a useful fuel. When you burn that fuel, you re release that carbon dioxide into the atmosphere, but it's a net carbon neutral process because it's just the carbon that was fixed by the plant that you are putting back into the atmosphere. So there's no additional carbon being added to the atmosphere. That's what the proponents of bioenergy say when they promote it as a climate friendly solution. Modern bioenergy systems can include both solid fuels, but the more common form are actually liquid fuels. The most common sources of bioenergy are actually crops like corn and palm oil. You might have heard of ethanol from corn or biodiesel from palm oil. There's also all these new generations of biofuels, third generation, where they're trying to generate energy from algae, and fourth generation, which are electrofuels and photobiological solar cells. But those are all experimental systems right now. The most commercially viable sources of biofuels still tend to be from crops like corn and palm oil. So I should confess that I was actually a big fan of bioenergy about 20 years ago. I lived in Sri Lanka and I worked in the clean energy sector. I actually worked in the solar energy sector, but I heard about this experimental dendrothermal power system that had been set up, and I was very curious. So I spent a couple of days studying this and I wrote a magazine article about it. I also took all these photos here on the right. And what this system did was it used wood, wood chips from a fast growing woody perennial crop. It subjected it to gasification and generated fuel that was then used for electricity production. However, I have since rethought rethought whether bioenergy is actually a sustainable source of energy, and the reason for that has to do with articles like this, which started coming out about 10 years ago, really questioning whether bioenergy is actually sustainable. And so if you look at this headline from the left, it says EU labels biofuel from palm oil as unsustainable. And then if you look at this New York Times story on the right, palm oil was supposed to help save the planet. Instead, it unleashed a catastrophe. So what actually was going on was that the EU was heavily promoting biodiesel as a sustainable fuel, but all this biodiesel was coming from palm oil plantations in Southeast Asia. And to create these plantations, the people there were deforesting tropical rainforest. They were cutting it down in order to put in the plantations. So, of course, that is very unsustainable because the tropical forest actually fixes a lot more carbon than the plantation was fixing. So, it ended up actually being a real disaster, especially from a biodiversity and wildlife perspective. You were destroying critical habitat for endangered species in order to grow this fuel crop. Let's also just talk about this issue of marginal land because it comes up all the time when people talk about bioenergy. There's this idea that there's all this marginal land out there in the world that can be used to grow bioenergy crops. So one should sort of take that with a little bit of, or more than a little bit of a pinch of salt, because a lot of this marginal land is actually used by poor people. It's often grazing land, or it's used for small scale cultivation. So it's not really empty land the way people think about it. The other issue is that if you want to really grow biofuel crops quickly, you're going to need a lot of water. Even if they are drought resistant crops, you still need water to grow plants quickly. So Is our marginal lands really the right place to do this? That's another question. And these two articles, which are academic articles from journals, bring up this question of whether marginal land is whether there is really all that marginal land out there for biofuels. So this one on the left, Jatropha potential on marginal land in Ethiopia, reality or myth. Jatropha is a very popular crop for biofuels. And really what this article concludes is that there's not all that much marginal land out there. A lot of it is being used by people already. And this article is also interesting because it questions the use of remote sensing for identifying marginal land for agrofuel development, precisely for the same reason that remote sensing misses out on things like the fact that people might actually be using this land for purposes like grazing. In general, if you look at the academic literature on biofuels and bioenergy, all of the articles point to challenges and limits to using this globally as a sustainable fuel source. So, this article, for example, does replacing coal with wood lower CO2 emissions? It actually concludes that in the short run, it does not. And even in the long run, the payoff is actually very long. This article here brings up this interesting question of indirect land use changes. So what does that mean? Take the example of British Columbia, which is the case study they are using here. Say you converted your existing agricultural land, some percentage of it, to growing crops for biofuels. You're still going to need the same amount of food. So what's going to happen is that food production is now going to get shifted elsewhere. So you really need to think about where that food production is now getting shifted to. This is your indirect land use impact, because if now that food is going to be grown on agricultural land that's being created out of the Amazonian rainforest, well, that is not a sustainable impact at all. So you have to actually think about the indirect land use impacts of biofuel development, especially at scale. This article here also looks at it from a global perspective and finds that there are real limits to using bioenergy for mitigating global greenhouse gas emissions. Okay, enough on biofuels for now. Let's talk about nuclear energy. So again, nuclear energy isn't really a sustainable form of energy unless you're getting it from fusion. So there's two main ways in which nuclear energy can be produced. There's fission, where you essentially split an atom, and there's fusion, where you're squishing two atoms together. Both processes can generate vast amount of energy. Fusion is basically what happens in the sun, and it would be awesome if we could get fusion energy. However, right now, all commercial nuclear power is fission based. And the experience really depends on context. So the proponents of nuclear energy say that it's a carbon-free source of cheap energy, and it's especially good, reliable baseload power. So if you now remember those load duration curves from the electricity section of the class, you'll remember that coal really sort of plays this role of providing baseload power in many parts of the world. And nuclear can provide the same kind of power, reliable. You can just always keep your nuclear power plant on. Unlike variable solar and wind resources, it doesn't really go up and down. So it's reliable, it's cheap, it's carbon free. That's what the proponents say. Of course, the actual experience of nuclear power really varies a lot by country. In France, for example, they generate 75% of their electricity from nuclear energy. They've done so for a long time. They have pretty good systems in place for managing the systems, for dealing with waste, etc. In the US, we have quite a different experience. We haven't really been able to build or commission a new nuclear power plant in almost a decade. There are two reactors under construction in Georgia. They have been beset with delays and cost overruns. It's become very costly to build new nuclear energy in the US, and it's very hard to site a new nuclear facility as well, because pretty much no community wants a nuclear power plant located by its town. Let's look at the economics a little, and this is just data from Lazard, which actually does all this research on the economics of energy and produces all the data. This data is only from the US, And if you look at nuclear here, you can see that this range of costs is a whole lot higher than the equivalent range of costs for wind and solar PV thin film utility scale. So you can ask the question whether in the US at least it makes sense to be building new nuclear energy systems. Of course, there's a whole bunch of experimental technologies out there, and there's companies, startups that are really trying to get these different forms of nuclear energy up and running. There's this company called General Fusion that's trying to get fusion systems up and running. Right now, everything is just experimental. No one has actually managed to build a commercially viable plant, but it's interesting space to watch because it could really be a game changer if somebody is able to, say, build a fusion plant and run it safely and cheaply. In the end, it all comes down to your gut feel about nuclear energy. There's these raging debates on Twitter between nuclear proponents and people on the other side, just within the climate community alone. And so much of it is not really based on data or analysis and just kind of on the image that you hold in your head of what nuclear power really represents. So on the left here, you see this is an image from the nuclear catastrophe that occurred in Japan after the earthquake and tsunami that took place in January 2011. It's the Fukushima Daiichi power plant. And if you remember, there was a large amount of radiation that was released into the atmosphere as well as into the water because of this accident. On the right here is an image produced by a nuclear think tank and research organization in the US of what the future of nuclear energy could really look like. Small, beautiful, modular systems, very safe enough to locate in the middle of cities. And so this is what the proponents see as the future of nuclear energy. And though there are quantitative ways of calculating the risk of a infinitely small yet potentially very catastrophic disaster like this. So it's an infinitely small chance of a potentially large catastrophe. You can quantify these risks. A lot of what people think about nuclear energy really comes down to gut feel and fears versus these kinds of images that the proponents hold. So I'll leave it there with nuclear energy, and that's all we have time for in this video.